Hello everybody. I, Neetu Mane M, Faculty of EEE Department, Sai Vidya Institute of Technology, welcome you all to the Basic Electrical Engineering Lab of First Year Engineering course. In Experiment 2, previously, we learnt about the relationship between line and phase quantities in AC of star and delta connected loads. In today's session, we are conducting Experiment 3 and learning to measure the three-phase power using two-wattmeter method for both star and delta connected loads. What is power? Power, it is the capacity to do work. In three-phase power, it is usually generated by using three-phase alternators. As we utilize this power for accomplishing heavy tasks such as industrial loads, grinding, milling, etc., then pumping underground water to overhead tanks, electric trains like metro, overhead transmission of three-phase power from one point to another, elevators, etc., we need to know how to measure the three-phase power. Three-phase powers can be measured by using two methods. The first one is 3 wattmeters method, where 3 wattmeters are used to measure the power in three-phase system, where power consumed by each is determined separately. Next one is the 2 wattmeter method, which we are currently emphasizing in this experiment. In 2 wattmeter method, 2 wattmeters are used to measure the power in a three-phase star or delta connected balanced or unbalanced load. Now let us learn about the circuit diagram to conduct this experiment and also the apparatus required to accomplish the same. So the apparatus required through the circuit diagram, let us understand. We need an input which is three-phase AC input, 450 volts, 50 hertz supply. Alright. Then we are using load such as this is a lamp load which can be connected in star or delta connection based on requirement. Then measuring instruments such as AC voltmeter, AC ammeter and AC wattmeter. We are using only one voltmeter, one ammeter AC and 2 wattmeters because we are conducting the experiment in 2 wattmeters method. The voltmeter is of the range 0 to 600 volts, ammeter is of the range 0 to 2 amperes and the wattmeter is of the range 0 to 2 amperes, 600 volts and UPF in nature. So this is a wattmeter and it has 4 terminals. This is for your easy understanding of how the wattmeter connections are in the terminals. So M and L, this form a current coil. The current coil is always in series with supply and the load. Alright. Then these terminals, M refers for mains, L refers for load. The M terminal, abbreviated as mains, is always connected towards the supply. The L terminal, indicated as load, is connected towards the load. Alright. And the potential terminal, C, is indicated as, abbreviated as common, and V is nothing but potential terminal. This is called as potential coil, and this is always parallel to supply and load. This, if we put it like this, you will have it parallel to supply and load. And the M and L will always be internally connected. Similarly is C and V. Whereas to connect the points M and C, always an external connection has to be done. And even from M outside, from L outside, from V outside, we need to build external connections along with M and C. Alright. Now, the point where the potential coil as well as the current coil meet is called as a common and is indicated as the terminal C. There are two types of wattmeters generally, such as UPF and LPF. UPF stands for unity power factor, where cos phi is always equal to 1. And is used for resistive loads. Whereas LPF stands for low or lagging power factor, where cos phi is always lesser than 1. It is used for inductive loads. So in this particular experiment, since we are using resistive loads, these are lamps, right? So they are resistive in nature, and since these are resistive loads, we are using a UPF wattmeter. Alright. Now let us see how to conduct the experiment. Conduct the experiment practically. So comparing the circuit diagram we had just seen, we have input supply which is of three-phase in nature, and there are three terminals R, Y and B. So these are the terminals R, Y and B. Then we have the TPST switch. So this is called a TPST switch, which means when you move it with a single hand, all the three switches will move parallelly. So this is TPST. And then we have a fuse for the internal switchgear protection of the whole circuit, because we're dealing with heavy voltage. And then we have ammeters and voltmeters as measuring instruments, isn't it? So we are using an analog device here. So this is a voltmeter AC type, and there are three terminals, common, 600 volts and 300 volts. So depending on the input that we are using to measure, we can either connect it with 300 volts terminal along with common, because common is a mandatory input terminal that has to be connected, and you can either choose 600 or 300 depending on the range of the voltage that you are trying to measure. Alright, and similarly is the ammeter. This is again analog type here, and in this we have a range of 5 amperes or 10 amperes. So common is the, there are three terminals again. Common is the mandatory input terminal that has to be connected, and from the other end you can choose either 5 amperes or 10 amperes based on the need of the circuit. And so in analog voltmeter, you can see, I told you that there are three terminals, isn't it? Common, 600 and 300. If we connect the terminals between these two leads, then you have to take the readings on the upper arc of the display meter. The needle will actually deflect and indicate a point, and you have to mark the point at which the needle coincides with the reflection in the metallic strip given here. So you see a metallic strip here, isn't it? So when whatever is the reading that it corresponds to, you will have to take that reading into consideration. Now let us go to analog ammeter. In analog ammeter, common 10 amperes and 5 amperes. So here you can see in the display scale, you have 0 to 5 amperes in the lower arc for reading, and you have 0 to 10 amps in the upper arc for reading. So this can be utilized for both the ratings depending on the need of the circuit. So in case I am using the ammeter to connect or to measure a 5 amperes range, then common and 5 amperes will be connected. Amperes will be connected, and here we will take the readings from the lower arc. Alright, so you can carefully have an idea about how it is made. Now coming to the wattmeter, which is of analog type again. So coming to the wattmeter, we know that we have 4 terminals, isn't it? M, C, L and V. Now let us see how it is in the practical device. So this is an ammeter, analog type. This is a wattmeter, which is of analog type. And the terminals M, L, this is mains, load. They will have an internal connection between these two. And this is a current coil. Okay. Then common, and this is V. So in V you have different ranges. You can make a choice based on the need of the circuit. And this C and V, either of them will have internal connection, and you have to externally establish a connection between M and C externally, always whenever you use a wattmeter for connection in your circuit. And this wattmeter also has 2 different ranges for the current. One is 10 amperes and 20 amperes. So based on the connection here, if they are connected in series, there are 4 terminals here called B1, B2, E1 and E2. If B1 is serially connected with B2, alright, they always are used to record the lowest calibration of the wattmeter in current. And if we try and connect the terminals such a way that B1 gets connected to E2 and B2 gets connected to E1, that means to say they are connected in parallel, then the wattmeter is calibrated to measure the high current range of that device. In this condition, the same wattmeter will be used to read higher higher current rating. Alright, but for this experiment, we'll be limiting it to lower current range because we have the necessity only up to that. Now let us learn how to calculate the wattmeter constant for wattmeters. Every time we use a wattmeter, along with the reading that it is displayed on the wattmeter, we also have to multiply it with the wattmeter constant because we are using it to calibrate it for the need of the experiment. So here we have the formulae which is given as K as V range into I range into power factor in the wattmeter divided by full scale reading. Now what is V range? V range indicates to the value of the voltage that you have used to connect for V terminal. In this particular experiment, we are going to use it for 3-phase measurement. And that will come up to 415 volts per line, isn't it? So we are going to connect it for 500. Always remember, measuring instruments must be used which are greater than the actually rating of the device. If I use 250 volts, it will unnecessarily damage the device, that is the wattmeter, and also spoil the circuit's behavior. So the V range that we use in this experiment is 500 volts. And the current that we use in this particular case will be the lowest current because we need less current rating. So I am going to connect B1 and B2 in series so that the whole wattmeter is used to calibrate or use the I range as 10 amperes. So voltmeter range is 500 volts and current range is 10 amperes. And then power factor in the wattmeter. Please note that this is a wattmeter which is used for unity power factor. So that is given as 1 dot here. Alright. So this is a device or this is a wattmeter which is used to measure either AC or DC. Remember, DC power factor is always unity, and hence this wattmeter is used to measure AC load which is having a unity power factor, or also can be used for DC. So we are using this for measuring AC load which is resistive in nature with unity power factor. And so in this formula we get VR is 500 volts, IR is 10 amps, and power factor in the wattmeter is 1 divided by full scale reading. Coming back to the device, we have the full scale reading in the meter going up to 2500 watts. Though the number indicates only 2400 here, the number indicates only 2400 here, it has divisions after that also, and that is 2500 watts. So VR is 500. Now, wattmeter constant, we know the formula, right? So substituting the value for the wattmeter 1, that is what we had used now to take the readings, K1 will be calculated as 2. Similarly, for the second wattmeter that we use in this experiment, we have the similar type of range for both the wattmeters, and K2 is given as 500 into 10 into 1 divided by 2500, which is 2. So every time you take a reading from the wattmeter, you have to multiply it with the respective corresponding wattmeter constants and then put it in the tabulation. Now let us see how to rig up the circuit. So in the circuit diagram, now we see that from R terminal it has come to TPST. So internally all these connections are done, and from the TPST we have the terminals coming out at this point. Alright, and from this point we will further connect it to the place of requirement. So from this end of R we are connecting it to one end of the ammeter. Alright, So in this ammeter, since we are using a range of 5 amperes, I'll be using common as well as 5 amperes terminal. So one end of this R terminal will come to common point. And from the other end of the ammeter, 5 amps, it will be connected further to the mains of the wattmeter. So this will be considered as wattmeter 1 and we are connecting it to the mains point. And remember, mains and common must always be connected externally, isn't it? So we are using another coil, another lead and connecting this to the common terminal.
That's all right.
Now, after we have mains and common connected, further with the load terminal, we will connect it to the point where we have the load SR, FR, SY, FY, SB and SB. So this is the resistive load that we have taken. This is the resistive load that we have taken, in which we have the points SR, SY and so on, right? Since we are doing this experiment for star connection first, let us connect this part of the circuit in star and then connect it this side. Okay, since in star connection all the similar ends meet, I have connected, I'll be choosing the end points to meet at a point as indicated in the circuit diagram. Like we have FR, FY and FB meeting at a point. FR will meet FY and then we have FY connecting to FB. Alright, so the star load is now ready. Now from the wattmeter, the end where we had the load connection connected, from here it will come to the point SR. So from here it is connected to the point SR. Then now we had just finished connection till this point. Alright, now we'll take the point from Y, which is directly got connected to the point SY. So the line is connected from Y point to SY point. Okay, then we have the point from B, which goes to the other wattmeter W2 mains terminal. So we have B, which has come to the point where we have mains terminal, and we also have to connect the point where M and C should be connected externally. So this is the point, M and C will be connected externally. Alright, M and C is connected. From M, L is internally connected, and from the load side it should go to the point SB. So from here, from the load side, it will be connected further to the point SB. Okay, now we should now connect the potential terminals of both the wattmeters, isn't it? M and C is shorted. C is internally connected with V. From V, we have to bring it to the point where it is connected to SY. So, in C, we are using the voltmeter range of 500 volts, isn't it? So, from 500, it will be now connected to the point SB. Now, from the wattmeter 1, I'll take another wire and connect it from the V terminal of the wattmeter 1 to the point SY. Alright, now the circuit is complete. We have connected all the circuit connections. Let us now connect the voltmeter across the line terminals. Since this is a balanced circuit, we can either connect it between RY or YB or RB. For this example, we are connecting it across the points R and Y. So now, from common and 600 volts, this will be connected to the point Y and R to measure the voltage, to measure the line voltage. Our circuit is complete, where all the measuring instruments are connected from the load till the from the supply till the load. Alright, now let us switch on the circuit and see how the circuit operates.